Hey guys, welcome to Surfing Mixed. In this video, I will let you know the importance of the law of cosine and will derive the relation for that. For right angle triangle, we know that we can find every aspect of the triangle if we know about two parameters. That is either the length of two sides or the length of one side and an angle of the right angle triangle. Then we can find every aspect of the triangle by using Pythagorean theorem and similarly using the different ratios, different trigonometric ratios. Similarly, if we know about the lengths of two sides and the corresponding angle between the two sides, we can find every aspect of any triangle, and that we do with the help of law of cosine and some other trigonometric relations. So in order to understand this, I consider a general triangle in the form and I represent the vertices with A, B and C, and I represent this angle with A. Let me call that angle A. Then I call this side A, this side B, and this side C. That is, we know about the length of side AB and the angle between them, and I want to find the length of side C. So for that, I first need to drop a perpendicular from the vertex C on side AB. Being perpendicular, this is 90 angle and this is 90 angle. That means we split the total triangle into two right triangles, and I denote this. Let me write the B a little away over here, and I denote this point with P. Then if I know the angle A and the side length of AC, which is small a, then I can find the length of this perpendicular, which is CP, and also this one length from A to P, and that I can do by using the trigonometric relation for right angle triangle. Since CP divided by hypotenuse is equal to sine theta, therefore I can write CP, the length of CP is A sine of A, and similarly the length of AP is equal to A times cosine of A. So that's what I use the ratio of the right angle triangle, and then I can write C squared, that is, this is the hypotenuse of triangle PBC, right angle triangle PBC. So I can write C squared equal to PB squared plus CP squared. That is, the side length C squared equals PB squared plus CP squared. Since we know the value of CP in terms of the two known parameters, that is the length of this side and the angle A at this corner, but we don't know PB, this length. So what I want to do, I want to transform this length in terms of the known parameter, that is B and this angle, and from this side I can write that AB equals AP plus PB. That is, the side length AB is in fact equal to AP plus PB, and AB is known to us, which is B. AP is known to us from this relation, which is A cosine of A plus PB, and from this I can find PB equals B minus A times cosine of A. So now in this equation I can write not this is so this equation C squared is equal to PB squared, and PB is now known in terms of the three known parameters, that is B, A, and the angle A, and similarly CP is known to us from this one equation. So putting the values from this equation, let me call this equation 1, this equation 2, this equation 3, and this one equation 4. So putting the values from equation 4 and equation 1 and equation 3, we can write c squared equals, for PB I'm writing this thing, b minus a times cos of a whole squared, because this is squared, and similarly for CP I write there, so that would become a squared sine squared a. This is composite square, so I open the brackets. I can write this as b squared plus a squared cos squared a minus 2ab cos of a, and then plus a squared sine squared a. I can combine the second term in the last term by taking a squared common for these two terms, and can write this as b squared plus a squared into cos squared a plus sine squared a minus 2ab cos of a. Now, this is the trigonometric identity, and we know this thing is equal to 1. So this whole terms gives me a squared, and I rewrite the final relation in the form of a squared plus b squared minus 2ab cos of angle A. That is, if we know about the two sides and the angle between them, we can find the length of the third side, because on this side we have all the three known parameters, so we can find c squared, and from which by taking square root we can find the side length c. And once we know all the three sides with this angle, we can find the area, we can find the perimetry, and every aspects of this triangle. So this is what we call law of cosine. That is, law of cosine gives us the length of unknown side of a triangle if we know about two sides and the angle between them. Similarly, instead of this angle, if we had the information of this angle, which I represent with C, and then I would have dropped a perpendicular on this side, and we would have split this triangle in terms of these two right angle triangles, and solving the same way like this, I could find A in terms of B and C and the angle C. And so I would be able to write B squared equals A squared plus C squared minus 2AC cos of angle C. So we can construct relation for inside if we know about two adjacent sides and the angle between them. So this is what we call cosine law, and we use it to find the length or the side length of a triangle in general, not necessarily a right angle triangle. Now, if the two sides are perpendicular, that is, instead of an angle theta, this is 90 degree, then we would have a right angle triangle, and this angle would be equal to 90 degree. This angle would be equal to 90 degree. We know cos 90 equals 0, so this term goes to 0, and we are back reduced to the Pythagorean theorem. So the cosine law reduces Pythagorean theorem if the angle between the two adjacent sides is 90 degree. Thanks for watching.